Guess, good afternoon, guys, or good morning. What I'm about to show you right now is just the continuation of the review that you have seen in my class. And if you haven't been to my class, I mean, this is just a continuation of what you will see. Okay, and so the first thing, like I mentioned in my class as well, guys, some of the things you're going to need to remember are these right here, the dot product. Oops, can't see that here. Which we're about to use right now also. This is u1v1 plus u2v2. Okay, that equation you need to remember. How do I find my magnitude? Again, these are equations you need to remember. Square root of x squared plus y squared. For polar coordinates, guys, you need to know if I'm going from polar to rectangular. Okay, you need these equations, both of these. X is equal to r cosine theta. Y is equal to r sine theta. Okay, so you do need to remember those. And the last set that you need to also remember are these right here. Rectangular to polar. Oops. Where r is equal to square root of x squared plus y squared. So pretty much the magnitude again. And also tangent theta equals y over x. So don't forget, you need to remember these. So study them, remember them. You will need them tomorrow. I don't think this test is hard, but if you don't remember these equations, it will be difficult. Okay, so we're going to go through some of these example problems here. Okay, so I know these are a little bit blurry, but these are asking, are these two parallel or orthogonal? And remember, if I have orthogonal, the dot product equals 0. Okay, so I'm going to do that here. This is, I need to use u1v1 plus u2v2. Okay, so if I look at these two right here, I'm going to do 2 times negative 9 plus, use these two numbers here, 18 times 1. This is negative 18 plus 18. This equals 0. So this is orthogonal. Okay, so that's how I can tell. If I did the same over here, again, u1v1, so this is going to be 3 times 9 plus negative 2 times negative 6, so, excuse me, not 18. 27 plus 12, well, this is going to equal 39. This is not orthogonal. However, if I look at these two numbers, if there's 3 times 9, or I mean, if I multiply by 3, so 3 times 3 is equal to 9. And if I multiply negative 2 by 3 also, it equals negative 6. So they may not be orthogonal, but these are parallel. Okay, so that's that for that one. Next problem here. A lot of y'all were asking me, like when you started going over this, the day I gave you the reviews. And here I have an x equation and a y equation, and it gave me a parameter, negative 1 to 1. Okay, and so what I'm going to do is, all you need to do is graph these guys. So I'm going to have a t column, something for the x, and something for the y. Okay, so they told me my t is between negative 1 and 1, so that's what I want to use as my boundaries, negative 1, 1, and we'll choose something in the middle. We'll choose 0. And all I'm going to do is plug in this into my equation. So this is negative 3 times negative 1. My x equation is negative 3t plus 1, and then plus 1. So negative 3 times negative 1 is positive 3, plus 1 equals 4. That's my x. And we're going to go ahead and do that for the rest of these x's. Okay, and so negative 3 times 0, because that's a t, plus 1. So this is 0 plus 1, which equals 1. negative 3 times a positive 1 plus 1. So this is negative 3 plus 1, which equals 2. So I'm going to do the same now with my y equation, which is 3t squared minus 4. And I'm going to keep plugging in this t value. Okay, so 3 times negative 1 squared minus 4. So here negative 1 squared is 1, so this becomes 3 times 1 minus 4. 3 minus 4, which equals negative 1. Okay, do this again with a 0. 3 times 0 squared minus 4. This equals, 0 squared 0, so this becomes 0 minus 4 is negative 4. 3 times 1 squared minus 4, so 1 squared is 1, so 3 minus 4, negative 1. Okay, and what these are points now. So I'm going to go to 4, negative 1. 2, 3, 4, negative 1. Positive 1 and negative 4, so positive 1, and then 1, 2, 3, and 4. Positive 2 and negative 1, so positive 2, negative 1. And if I connect these, that's the way my graph looks. Okay, so all you have to do is plug in the t values and look at your boundaries here, so you can see what they are. Okay, so moving on, eliminating the parameter. And so again, these are parametric equations, guys. I have an x, I have a y. Remember that I do want it to say y equals something. So here I'm going to use my x equation, x equals t plus 1. And I want to solve for t, so it's going to be minus 1, t equals x minus 1. And I plug this in to my y equation. So y is equal to 2 times t, which I know is x minus 1. Then I distribute, so it's 2x minus 2. And that's it. This is my equation. This is my answer. Okay. Last thing here, plotting polar coordinates. Okay, so here I'm going to go start. You start with the r and theta. You don't start with the angle first. So 120, you go to 120. It's right here. You go to the middle, and this one's telling me to go 1 out. So 1 out. That's my first point. So I go in pi over 3. So you go to pi over 3. You go to the middle, and this one's telling me to go 2 out. So 1, 2 out. Negative 45. So remember, when you have negative angle, you start here. So I'm going to go to positive 45. Negative 45 is across. So it's this one right here. So I go to the center, and then I go 1, 2. This one's telling me 3 out. And the last one, 420. This is not on my unit, on my circle, so I'm going to subtract 360. This is going to equal 60 degrees. And here, so I go to 60. And I go 1, 2, 3, 4 out. And that's my point. Okay, so again, guys, study. You will continue if you have not already gone to my class to study for this test. It is tomorrow, so keep at it. Okay, bye.